Welcome. This is lecture number 17 of part 2. Class number you refer, I think 58, I think most probably. Question number 2. I'll give the question by words. Then see it. Words I'll give. A cylinder of weight 10 kilonewton is placed on an smooth inclined plane which makes an angle of 40 degrees with horizontal. What push along the plane is required to prevent the cylinder from sliding down? That is the question. Okay. See, they told smooth plane, 40 degree angle with horizontal, cylinder of weight 10 kN. What push is required to prevent it from sliding down? So push should be like this. It can't be like this, because why? Think a little. If you push this way, cylinder is already rolling down. If something is placed on an inclined plane, if you push it down, it will go faster. So to prevent P, remember, friction is not there. Now there is one important. There is a unique value of P. Only that much P should be applied for equilibrium. If you apply lesser P, this will start coming down, not sufficient. Suppose you apply more P, cylinder will start moving up. This is in the absence of friction, but not when friction is there. When friction is there, there is a range of P, that all we discuss later. So this is a question number 2. Solve now. See, first I will tell class. I already told so many times for you. Once you write the question, do not write anything in the question, because we are going to enter some reactions now. If you enter in the given question only, later when you study, doubt will come, which is given, which is not given. So make a habit in my entire course. If a question is given, then do not write anything in the question. Okay, now solution start. Write the sketch once again. I will not write, because why? I am not learning, I am teaching. Then write here. See, let R be normal reaction. P with the push. You write here. You should write R be normal reaction to the contact surface. This all I told you earlier. And they told simply, they are not told P. And let P be the push along the plane. Okay, now write free body of cylinder. See, this is the cylinder. Its weight is acting down. How much weight? 10 kilonewton. Then one force push is coming here. It will actually touch the center if you extend. P. It makes an angle of 40 degree with horizontal. Then here there is a normal reaction. See, to the plane. The plane is here. See, somewhere here is the plane. To the plane there is a normal reaction. R. This also, if you continue, will meet here. Let the joint be O. This is free body. Now, what is this angle? See here. I told this is normal to the plane. Actually, it's out of scale. Okay, you can manage. See, or see here. This is 40 degrees. This is 90 degrees. This is 50 degrees. You calculate. Or there is a rule. If an inclined plane, or see here, see, if you dot tangent, this is the plane, this is 40 degrees, this is 50. Or there is a rule in mathematics. If any line makes angle theta with the reference direction, its normal makes 90 minus theta with the same reference direction. This inclined plane makes angle of 40 degree with horizontal. So its normal will make 50 degree with horizontal. Okay, that much common sense required. Okay, now Now this is to be solved. You got many options to solve. See, first, apply Lami's theorem. You write here. You should write correctly, Lami's theorem. If you apply Lami's theorem, consider the joint over here. See, P is coming here. This is P. P. This is R, normal reaction R. Weight is acting down. If you write it down this way, you cannot apply Lami's theorem. Why? Two forces are acting towards the point. One is acting away. Therefore, instead of writing there, you write it here. Now see, condition satisfied. You should write, yes, three forces are there in equilibrium and another point. All are acting towards the joint. Now, we want this angle. See, if this is 50, see here, if this is 50 degrees, see now, light line put here. If this is 50, this is also 50 degrees. 50 plus 90 is 140 degrees. Then this already I told you, if this is 40, this is 50, see, this is 40, this is 50 means this is 90 degrees. This angle, you can either go for 360 minus sum of these two, or see here, this angle we want. If this is 40, this is also 40. 40 plus 90 is 130 degrees. Those who are learning should correctly write. You write how you got 140 degrees, how you got 130 degrees, how you got 90 degrees. You write, add all the values, you should get 360 degrees. Now, P by Lami's theorem, P by sin 140 equal to R by sin 130 equal to 10 divided by sin 90. Solving, we will get the value. I write here now. Solving, we will get P equal to and R equal to. Of course, P is our answer. In the question they asked you P. Reaction is not required in the question, but still write the answer. P you will get. You get P in kilonewton, and also you will get the R in kilonewton. I have not solved actually. I will solve now. 10 into sine, calculator is not off. 10 into sine 140 equal to 6.428 is P. P is plus 6.428 Newton, and R is 10 into sine 130 equal to 10 into sine 130. 7.660 Newton plus 7.660 kilonewton. Okay, they are in not Newton, they are in kilonewton. Solution is over. Now, this is question is over. Now see, I will rub this one now. By Lami's theorem, we got the answer. Now what you do is, you understand each and everything. Don't suddenly tell we know everything. Okay, now, instead of Lami's theorem, suppose you go for basic conditions of static equilibrium. You write not this way, you should write correctly. If you are learning, if you want to learn everything, what all I dictate, you should write basic conditions of static equilibrium. Then you have to resolve the forces, or you can do, then you can refer this sketch only. But one thing, you need angle with horizontal, 40 degree, 50 degree. See, you write there. This is your XX. This is YY. Okay. Then sigma Fx equal to 0, take right side positive. See here now. If you resolve here now, see, this all, first of all, I should not waste time on these things. If this is this way and this way. This is directly. Or plus P cos 40, red I will not use, plus P cos 40 minus R cos 50, red you write R cos 50, that's all. This is no component, equal to 0, equation number 1. Sigma Fy equal to 0, take upward positive. Plus P sin 40 plus R sin 50 minus 10 equal to 0, equation number 2. Solve simultaneous equation 1 and 2, 100%, you will get the same answer. Okay. Now, this already I told earlier. Or you make a note. Whenever you solve an inclined plane problem, see here, you get simultaneous equation in terms of P and R. You can save time by changing x, x, y, y. Make a note. Okay, this is over now. Make a note. Make a note. What you do is some slight changes you have to make. Now, you consider, see, this is the plane. Now, alternate solution. Alternate, but easy solution. Right? Advantage for inclined plane problems. Plane problems. See, this is your cylinder. Contact surface. You take this as xx. Or you can tell x dash x dash. No. If you are solving this way, that xx is not there. This xx. And perpendicular you take yy. Yy. This way. Along the plane xx, perpendicular yy. Okay, then see here. This weight is acting down. How much? 10 kilonewton. See now, what angle this 10 makes with the xx we want angle. See. Now, this is 40 degrees. If this is 40 degrees, see here, then the angle made by 10 kilonewton with the xx, see here, this angle is 50 degrees. Where I will write? This is a cylinder now. See, I will maintain cylinder as it is. Okay. This xx is 50 degrees with the xx. You can mark here angle 50 degrees. Okay. No space there. I'll cut the cylinder 50 degrees. Then this is normal reaction. R. If this is 40 degrees, this makes with the xx axis. See, this is yy. But remember, take the angle with the xx only. This is with the xx. Oh, sorry, not angle. It is normal to y. No angle. It is R is perpendicular. It is directly along yy. Okay. Now, the force P, it is acting directly along xx. See, directly along xx. Only thing is 10 kN is making 50 degree with xx and yy not required. Now see what to do. This all I explained earlier. When xx, yv is this way and when you tilt it, go back to earlier classes. You should study sigma, okay, see, sigma fx equal to 0. See, take this positive, this way positive. Then plus p minus, see component here, see, for the 10 kilonewton, one component will be like this, one component like this. This is along the plane. Minus, actually you need not write inclined, you should write horizontally. Okay, to understand, I will write inclined. Minus 10 into cos 50. This has no component because this is directly along yy equal to 0. Directly you get the value of P in kilonewton. Let us check it. Checking not required. 10 into cos 50. 6.4298 kilonewton. 6.428 kilonewton plus 6.428 kilonewton. Now, sigma Fy0, take this way positive. See, somewhat this way upward. Then it is plus R. This has no component. It is directly along xx. minus 10 into this 10 kn is making 50 degree with xx. So y component is sine. 10 sine 50 equal to 0. Your r will come 10 into sine 50 is 7.660 Newton. See? Over. Therefore, answer is same. Now, more you can make a small note. Here we will not use much. Little later, when you go to friction chapter, not right now, when you go friction chapter, we will solve plenty of problems on inclined plane. That time, I will explain much more clearly with the neat sketch of the inclined plane. Then I will tell. Now do one thing. If at all there some confusion was there earlier questions, in equilibrium questions, now go and study. Okay, this question is over. I will prepare next question. I will give two questions. This is for you to solve, or like exercise. Oh, it started raining here. Okay, hope rain is not severe. See, just a minute. I should stop. I'll remove this one, not required. Okay, now, two questions I'll give you. This question. This is same as last question. I'll give by words. By words I will give you. A cylinder weighing 6 kN is placed on a smooth inclined plane, which makes angle of 30 degree with horizontal. What pull along the plane is required to prevent it from sliding down? See, pull means now surely you can't pull this way. If you pull this way, it will come down. This is trying to slide down. So pull should be that way. Let P be the pull. Okay. Same as last time. See, I will write here now. See, normal reaction. First you write the question, then write everything, and then weight is acting down. Now solve the question happily. Weight is 6 kN. Either apply Lami's same as last time. This P was from this side, now that side. So solve. I have given answer. Correctly solve. Next question. A block weighing 12 kN is placed on a smooth inclined plane. Smooth inclined plane. I told now onwards in this chapter, right now for equilibrium, till we go to friction, every surface given is smooth, which makes angle of 50 degree with horizontal. To prevent it from sliding down, a cable is attached along the plane. Attached. Find the tension in the cable. First you write the question. Okay. Then second time sketch. See, instead of weight 12, you show the weight here. How much weight? 12 kN. Then see, put a normal reaction here, and tension in the cable is like this, T. Now you consider this. See, when you consider free body of the block, you should take this tension. See, that is same as this P. So now this question is same as this question. Values are changing. Instead of P, it is T. Solve, you get the value of T and R. That much effort you have to give in my class. In the notes also, these two questions, I will start, write free body, then I will give the answer. Because why? Even those who are using the notes, there should be some effort from their side also. It is not that everything is given there. Of course, questions, more and more questions will be solved. Okay, now I will prepare the next question. Next question. A cylinder is placed between two inclined planes as shown in figure. These can't be explained in words, as shown in figure. See, this is between, question is, a cylinder is resting between two, once again, smooth inclined planes. I told once again, smooth. Again I told, smooth. By words only given. Smooth inclined planes. Cylinder weighing 6 kilonewton. Find the reactions at the contact surfaces. Okay, very important question for entrance examination solve. Okay, start. First you put the sketch. Okay, then do one thing. This contact point I will take A, this contact point I will take B, center I will take O. Okay, now write, this is first sketch. First time you write without naming. Okay, then once again write the sketch. Now, see, there is a reaction normal here. There is a reaction normal here. See, it is normal. If you extend, it has to pass through center. This is reaction at B. This is reaction at A. Write this way. Let RA and RB be reactions on the cylinder at the two contact surfaces. Now, consider point 2. Now, consider free body. Actually, this itself is free body. Okay, now, consider these three forces. See, weight is 6 kilonewton. So, now second time sketch, what you do? You show the weight. Second sketch, you show the weight of 6 kilonewton. When you put second time. Okay, now, see here. Point C is here. This is your RA. RA. This is your RB. RB. Weight is 6 kilonewton. See, weight is 6 kilonewton down. Now, this is making angle of 40 degrees. This is also making angle of 40 degrees. Now, if you use, now you cannot do inclined XX. Two inclined planes are there. Now, see, if that is 40, this also 40 degrees, this also 40 degrees. Now, if you use equilibrium condition, sigma Fx equal to 0, take right side positive, plus RA cos 40 minus RB cos 40, that's all, equal to 0. So, RA will come equal to RB. Equation number 1. Sigma Fy equal to 0, take upward positive, plus RA sin 40. First of all, I should not explain this one. I am wasting time. Plus RB sin 40 minus 6 equal to 0. Therefore, you get, or you can do one thing, RA equal to RB. I will do one thing, call equation number 2. Solve 1 and 2. These all, I should not waste time. Your RA, red color, and RB, both will come. Solve it. Actually, very simple to solve. RA could RB means sin 40 into 2 reciprocal into 6. 4.667 kilonewton. Both will come plus 4.667 kilonewton. This also plus 4.667 kilonewton. Okay. Now, make a note. Or, if you apply Lami's theorem, see, RA goes this way. RA. RB goes this way. Now your 6 kilonewton, you should write from outside. Why? All incoming 6 kilonewton. This angle, if this 40 degree, this angle 40 plus 90, 130 degrees. This also 130 degrees. This will be 40 plus 40 is 80, total 180, therefore 100 degrees. Add everything, you will get 60 degrees. Now, therefore, by Lami's theorem, RA divided by sin 130 equal to RB divided by again sin 130 equal to 6 divided by sine 100. Solving, you will get RA and RB. RA, RB both will come equal. Why should I calculate? But still, okay. Still for academic purpose, 6 divided by sine 140 into sine 130 equal to 6.775. 6 point, no. 6 divided by sine 100 into sine 130. 4.667 kilonewton. I got a shock. 4 point. How it is possible? That too, when we are using two same equilibrium for both the cases with two different approach. Okay, this is solution. Now see here, this is 40 degrees, this is 50 degrees. Now your question 6 I will give. Question 6, what I will do is, I will change the two angles. That is for today's class last, because I do not want class more than 25-30 minutes. Because people can have no patience to go through hourly classes. Cut daily, I am almost uploading daily classes. Okay, I won't break. I'll continue. In front of you only I will solve. No question of preparing the answer. Okay, see, now question. One inclined plane is this way, one is little steep, other is little flat, lesser. Okay. This is a cylinder. So, see, my circle won't be difficult. See, that is the problem. That's why sometimes I write before recording. People should not laugh. He doesn't know how to draw circle solve. Okay. What to do? Adjust it. Circle, weight equal to 20 kilonewton. See, question. A cylinder weighing 20 kilonewton is resting between two smooth inclined planes. Smooth. As shown in figure, see angle. This angle is 30 degrees. This angle is 50 degrees. Oh, once again become 100 degrees, better, 50 better. 55 degrees, okay, 55 degrees, out of scale. Find reactions at all contact surfaces. Okay, put the question. It will neatly draw a circle. Now start solution. Write the sketch once again. Show the weight. See, luckily remember 20 kilonewton. Then see 55 degree over. There is a normal reaction here. RB, normal reaction here. RA. So you should write this point is O. This is your A contact point B. If you extend these two, it will meet here. Okay. Now, I think for this one, best is Lami's theorem. See here. If you apply Lami's theorem, see, RA goes this way. RA. RB goes little more stiff. This 30. This way. RB. Little more stiff. And 20 is like this. See correctly. This is 30 degrees. If that is 30, see this angle is 30 degrees. This angle is 60 degrees. Be careful. See, if this is 30 degrees, this angle is 60 degrees. You should write one more sketch. If this is 55 degrees, this is 35 degrees. Why? Because, see, perpendicular here. If this is, see, this is perpendicular. This is perpendicular. So, if this is 30, where 30? Sorry, this is 30, a little more neatly. I'll put it more neatly. This is how much? This is 30 degrees. If that is 30, this will be 60 degrees. Whereas, oh, I think this will go a little more, not steeper, little flat it will become. Okay. RB, no problem, okay. Now, same way, if this is 55 degrees, this is 35 degrees. Now, I want this angle. See here. This angle. If you want, do one thing. You write, if you want, you write light line here. Okay, now start. If this is 60 degrees, this is also 60 degrees. If this is 35, this is also 35. Right, write the sketch, no problem. Now see, this you can use for equilibrium. Okay, now go to Lami's theorem. Lami's theorem. Now go to Lami's theorem. 20 kilonewton. I am not maintaining scale. RA, RB. Scale is not required. Okay. 60 degrees, 35 degrees. So this will be 60 plus 35. 60 plus 35 is 95 degrees. This will be 85 degrees. This angle, 90 plus 35, 125 degrees. 90 plus 60, 150 degrees. Correct? Correct. Okay. Now apply Lami's theorem. Your answer is RA divided by sine 125 equal to RB divided by sine 150 equal to 20 divided by sine 85. Sine 85. You will get RA and RB. That's, 20 divided by sine 85 into sine 125. 16.446 kilonewton plus 16.446 kilonewton. Other one, 20 divided by sine 85 into sine 150. 10.038 kilonewton. 038 kilonewton. Okay. Over. Or I am concluding now. Or if you do not want Lamy, use this sketch. See. Resolution, see here. Tell this is XX. Now see, two inclined planes are there. Both are together you are considering. So now XX is usual. XX, YY. Sigma Fx equal to 0. Take right side positive. Plus RA cos 60 minus RB cos 35 equal to 0. Equation number 1. Sigma Fy equal to 0. Take upward positive. Plus RA sin 60 plus RB sin 35 minus 20 equal to 0. Equation number 2. Solving. Okay. Checking is not required. Still, mode alpha A, that is the simultaneous equation. Okay. Number one ones are 2. It is cos 60 equal to minus cos 35 equal to 0 equal to sin 60 equal to sin 35 equal to 20 equal to 16.446. Same answer. Solving, same answer will come. But important is what here? See, your important is if this inclined plane makes an angle of 30 degree with horizontal, its perpendicular makes 60 with horizontal. If this inclined plane makes 55 with horizontal, its perpendicular will make 35 with horizontal. That's a rule I told. If any line makes angle theta with a reference direction, its perpendicular will make 90 minus theta with the same direction. Earlier, by mistake, if I told once, I don't know, sometime what happens is, in the telling, I forget, I might have told earlier, no chance actually, if a line makes an angle theta with the reference direction, its perpendicular will make, by chance, if I told same theta, it is actually with the perpendicular direction. It is actually, if a line makes theta with horizontal, its perpendicular makes theta with vertical. By chance, maybe I am thinking of that one I told earlier. Or general rule is, I will tell you now once again. Remember, if a line makes angle theta with, say, horizontal, its perpendicular makes 90 minus theta with horizontal. Or if a line makes angle theta with vertical, its perpendicular makes 90 minus theta with vertical. Or one more, mixed together. If a line makes theta with horizontal, its perpendicular also makes theta with vertical. Or if a line makes an angle theta with vertical, its perpendicular makes theta with horizontal. Hope it is clear. See what I told? Once again, if there is an inclined line with horizontal theta, its perpendicular will make with the same horizontal 90 minus theta. But or if a line makes theta with horizontal, its perpendicular will make theta with vertical. Simple mathematics. Or difficult means do one thing. You come here and see here. See, you see these triangles. This is perpendicular. 60 means 30. Sometimes what happens is such a small mistake will spoil everything. Do not spoil. Okay, now I will conclude. Now next class I will go for that one. Other questions of which one? See, one cylinder here, one cylinder here. All these questions I will consider in the next class. Okay, thank you.